Welcome back to the last set of notes in Unit 4. The last set of notes in Unit 4 deals with word problems with rational numbers. We've talked about rational numbers earlier in the year, but today we're going to talk about using them in word problems. So let's go ahead and get started with that right now. Welcome back. Today we're going to be finishing Unit 4 by talking about word problems with rational numbers. Now this isn't going to cover all of the word problems that we talk about. However, this will give you a good idea so that when you run into word problems, you can use your logic and other things that you've learned in order to solve them. So let's go ahead and take a look at example A. Here we are at example A, and it says the graph shows the ages of students in Maple Hill Football League. And it has a couple questions for us. We've got a graph down there indicating the ages of the students in the football league. And a couple questions start with what percentage of students are ages 13 to 14, and what percentage of students are 15 or older. So we're going to have to take a look at both problems right now, but let's take a look at our graph and start with the first one. So the first thing we got to figure out is how many students are between the ages of 13 and 14, and I can't just look at one bar. If I look at one bar in my graph, I can see that this bar right here tells me that I have 300 13-year-olds, but I'm not just looking for the number of students who are 13. I'm also looking for the number of students who are 14. So I have to include both the 13-year-olds and the 14-year-old bars. And when I do that, I have 300 students that are 13, and I have 200 students that are 14. So I have to add them together. 300 plus 200 is going to give me 500 students. So now, since I'm trying to find a missing percentage, the best way to do that is to use a proportion. So I'm going to set up a proportion, knowing now that I have 500 students that are 13 or 14. I need to figure out some other parts of my proportion, though. In order to use it, I have to have three different numbers and then an x. So now, since I know that 500 are 13 to 14, I need to figure out how many students there are total. So in order to figure out how many students there are total, I have to add all of the bars. So I have to add my 50, my 100, my 300, my 200, my 100, and my 50. And when I do that, I get 800 students total. So let's move our 800 to the bottom because that's going to be our total. So on the top of our proportion, we've got the number of students who are 13 to 14, and the bottom that we've got total. Now we're looking for percent. We don't know what the percent of the 13 to 14-year-olds are. That's what the question's asking us. So we're going to make that X. Then I need to figure out the total percentage, and anytime I'm talking about percent, the total is always going to be out of 100. So it's going to be out of 100%, and I can slide that down to be my bottom number. Now I've got a proportion, so always to solve proportions, I'm going to cross multiply. I'm going to cross multiply 500 times 100, 800 times x. When I do that, I get 800x equals 50,000. Then I'm going to divide both sides by 800, and when I do that, I end up with x equaling 62.5%. So a little bit more than half of the students in this field are 13 to 14. And that makes sense. If you're looking at the graph, they are the largest bars, so that you could see that, yeah, they would probably make up more than half of the students. Now let's take a look at the second problem where it says what percentage of students are 15 or older. So again, I have to go back to my graph and take a look. So I want the students who are 15, that's 100. However, it doesn't say just the students are 15. It says the students that are 15 or older. So I have to also include the 16-year-olds. So that's another 50 players. So I have to add those two together just like I did before in order to figure out the total number of students that are 15 or older. So 100 plus 50 is going to be 150. And again, since I'm trying to find a percentage, I know that I have to use a proportion. So let's make this a proportion. Now I need to know the total number of students. Luckily, I found it last time. I knew it's 800, so I can just use that number again. Then I don't know what percentage of students are 15 or older, so that's going to be my x. And since we're talking about finding a percent, I know that that's going to be out of 100%. So now, again, I'm going to be cross multiplying. So I'm going to take 800 times x and 150 times 100. When I do that, I get 800x equals 15,000. Then I'm going to divide both sides by 800 to solve my equation. I end up with x equals 18.75%. And again, you can take a look and say, yeah, they're a little bit smaller than all of the other amounts there, so they're probably going to be a little bit less than 20%, and that makes sense. It's very important that when you're solving word problems that you make sure that your answer makes sense. So for the first one, if we had gotten 2% and you look at your graph, there's no way those two bars could have only been 2%. So it's very important that when you get an answer to your word problems, you perform a logic test. Does my answer make sense? If your answer doesn't make sense, you shouldn't write it down as your answer. You should go back and check your work. Now let's take a look at example B. So here in example B, it says Kayla works at Subway. She earns $9.70 an hour. She works 3 days a week for 7.5 hours each day. How much money will she earn in 4 weeks? Then it says she has to pay 11% of her earnings to income tax. So how much will she be paying in taxes over 4 weeks? So let's break this problem down and pull out the important information. So she earns $9.70 per hour. That's important. She works 3 days a week. Also important. She makes 7.5 hours each day. And how much money will she earn in 4 weeks? All important pieces of information. So let's start with how much she makes each hour. She makes $9.70. So now, if I know that's how much she makes in 1 hour, I need to figure out how much she makes in 1 day. And since the problem told me that she works for 7.5 hours, I can just take my 970 and multiply it times that 7.5 hours. And when I do that, then I'll be able to figure out how much she makes in 1 day. But she doesn't only work 1 day a week. According to the problem, she also works 3 days a week. So I'm going to take the amount of money that she makes in 1 day and multiply that by 3, because then that'll tell me how much money she makes in 1 week. But she doesn't just work 1 week. We have to figure out how much she makes in 4 weeks. So we're going to take our answer there and we're going to be multiplying it by 4, because that's the number of weeks that she works. So if we take those and all multiply them together, when we do that, we figure out that she makes $873 in that 4 weeks. So it was a lot easier to multiply all of those things together to give us the one answer. Of course, we could have taken our 970 times 7.5 and written that down and then multiplied that by 3 and then written that down and then multiplied it by 4. We could have done that and it's still gotten 873. However, it's a lot faster to just multiply them all together. So now let's take a look at the bottom problem. It says Kayla has to pay 11% of her earnings in income tax. So we're finding tip, tax, discount, or markup. In this case, it's tax. So I'm going to take my 3 boxes that I like to use when I'm solving a tip, tax, or discount problem. So I need to figure out how much money she earned over the 4 weeks. I just found that to be 873. So I'm going to go ahead and put that in my first box. Then I need to figure out what I'll be multiplying by, and the problem told me 11%, but I can't put percent in my calculator, so I'm going to have to turn that to a decimal, or 0.11. So I'm going to take my 873 times my 0.11, and when I do that, I get $96.03. So now I should do some subtraction. Oh, no, wait. The problem just asked me how much will she pay in taxes. So since I'm only trying to figure out how much she's going to pay in taxes, I know that's going to be this $96.03. I don't need to go any further because I'm only looking for the tax. Now let's move on to example C. So here in example C, it says Jake buys 4 pounds of jelly beans for 58 cents per pound. He buys 2.5 pounds of M&Ms for $1.28 per pound. He buys a third of a pound of gummy bears for $1.68 per pound. If Jake pays with a $20 bill, how much change will he receive from the cashier? So we have to figure out how much each thing that he bought is worth. Then we can add those all together, and then we can figure out how much he needs to pay and then how much he gets back after he pays with $20. So let's start with the pounds of jelly beans. So let's go through and highlight the parts of our problem that are going to be important for us to know. So 4 pounds of jelly beans is going to be 58 cents. That's important. 2.5 pounds of M&Ms is going to be $1.28. That's important. And a third of a pound of gummy bears is going to be $1.68. That's going to be important information. So let's start with the jelly beans. So I'm going to be taking my 4 pounds of jelly beans times my 58 cents, because that's how much the jelly beans are going to be worth. When I do that in my calculator, I end up getting $2.32. So that is how much the jelly beans are. But I'm going to add that to how much I pay for M&Ms. So again, M&Ms are 2.5 pounds for $1.28. I can't put that half in my calculator, so I need to know what half is as a decimal. That's 0.5. So I'm going to take my 2.5 times 1.28. And when I do that in my calculator, I end up getting $3.20. So now I figured out how much the jelly beans are, how much I pay for the M&Ms. So now I need to take my 1/3 pounds of gummy bears times $1.68 so that it can tell me how much I'm going to be paying for gummy bears. Now I can't put my 1/3 in the calculator unless I take 1 divided by 3 times 1.68. Remember, whenever you're multiplying by a fraction, you need to put that fraction in the calculator first. So 1 divided by 3 times 1.68. When I do that, I end up getting 52 cents for my gummy bears. So now I'm going to add those 3 amounts together, and when I do that, I end up getting $6.04. However, the problem isn't asking how much these items cost. It's asking how much money he's going to get back if he pays with a $20 bill. So we're going to take our $20 bill, we're going to subtract the amount of money that he spent, which is $6.04. So when we do our $20 minus $6.04, we end up getting a final answer of $13.96. And notice I labeled that final amount with a dollar sign because this is a word problem. I need to have a word answer, and in this case, my word answer is money, so that dollar sign is an appropriate label. Let's go on to the last example. Here we are at example D, and it says Kevin has a bank account with a beginning balance of $427.16. He writes checks for $52.13 and uses his debit card for a purchase of $19.12 at Giant. He makes a deposit of $395 and then makes an ATM withdrawal of $60. What is his ending balance? So we're first going to need to go through because there's a lot of information in that problem that's important to pull out. So let's start with his beginning amount of money. So it's a very important thing that we know the beginning amount of money that he starts with is $427.16. Now, he's going to be making some purchases, so we want to go through and find the things that are negative. So he's going to be writing a check for $52.13, so that's going to be negative. He's going to be spending money there. He makes a purchase of $19.12, so again, that's going to be a negative. He's going to be spending money there. He makes a deposit of $395. We know deposit means that that's going to be a positive thing. So that we can mark down as important as positive. Notice I'm going to be using green for positive. And then he makes a withdrawal of $60. So withdrawal, that's again a negative amount of money. So he's going to be taking money out. So now we have this information. Let's go ahead and start our problem. So we know that he's going to start with $427.16. Now, rather than going through back and forth with negative, positive, I'm going to just take away all the negatives first, and then we'll add the positive back at the end. So we know that he spends $52.13, so that's a negative. He makes that purchase with that debit card for $19.12, so that's a negative. And then he makes a withdrawal of $60, so again, that's a negative. So all of those things are money that he's going to be taking away from his account. So then I can just use my calculator, $427.16 minus each of those. And when I do that, I end up getting $295.91. Perfect. Now, that's all of the negatives, but he did put in a deposit of $395. So I need to take that amount of money, add to it the $395 that he deposited, and then that will give me his grand total. And when I do that, I get $690.91. Now, could I have done all the negatives in order that I'd seen them in the problem? Could I have done $427.16 minus $52.13 minus $19.12, then plus $395, then minus $60? Of course, that will also work. I like to break it out so that I have all the negatives happening at once and then all the positives happening at once, but both methods will get you to the correct answer if you type them in your calculator. Again, this is an opportunity to see, does it make sense? He only really took away small amounts of money, each one of them under $100. And then he added almost $400 to his account. So his account going up in the end does make sense. And I asked myself, does it make a logical sense that this happened? Yes. So it's important that every time that you do these type of word problems, you need to check with yourself. Does my answer make sense? If it doesn't, go back and check your work. If it does, you may have done it right. That brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, throw us a sub, and we will catch you in the next one.